Alright, we're going to start off with a derivation of the law of sines. So what the law of sines kind of does for us is we can take non-right triangles, or right triangles of course, but the big difference is that we can take non-right triangles and solve for both angles and sides of a triangle. So before, we might have had a right triangle and given a angle and a side, let's say 5 and x, we could have solved for x just using SOHCAHTOA. So in this case, sine of 30 is equal to x over 5, opposite over hypotenuse. Thus x would be equal to 5 sine of 30. And that works really well for right triangles. But in this, we would actually want to find a way to solve for sides and angles of a triangle that are non-right triangles. So I'm going to do something that you've seen before, which is take a non-right triangle, and I'm going to drop an altitude and create two right triangles inside. Alright, so I'm going to give some labels here. Let's call this A, B, and C, and their opposite sides, little a, little b, and little c. And the last time you saw this would have been when we were deriving the area of a triangle. And we're going to so I'm going to use that idea here. If you remember the area of a triangle, we actually found how to compute an area for any type of triangle, not just right triangles. And so this is, again, we're using the same kind of concept to compute sides and angles of a triangle for non-right triangles. Let me go ahead and label this altitude. Let's call it E. Alright, so I'm going to look at the sine of C, which is equal to its opposite E divided by its hypotenuse, A. I'm also going to set up that same kind of equation for the sine of A. So sine of A is equal to its opposite E over hypotenuse C. So solving for E in both of these equations, see, multiply by A, those would cancel. So E in this case is equal to A sine of C, multiply by C, those C's cancel, and E in this case would be equal to C sine of A. Alright, because E is equal to this and E is equal to that, we can thus say that these two things I just underlined must be equal to each other. So A sine of C is equal to C sine of A. And this is, I guess, technically the law of sines, but it's not usually how it's presented in any textbooks. So I'm going to do this, I'm going to present this how you would in a textbook. So I'm going to divide each side by AC. So doing that, the A's would cancel on this side, the C's would cancel on this side, and we would see that the sine of C over C is equal to the sine of A over A. And this is just 2/3 of the law of sines. We could have done the same exact derivation with B and A instead of A and C, and then we would have found that the sine of A over A is equal to the sine of B over B. Doing the others, you would have found that the sine of B over B is equal to the sine of C over C, and so on. So let me go ahead and now write out the full law of sines. So law of sines. The sine of A, big A, over little a, is equal to the sine of big B over little b, which is equal to the sine of big C over little c. And this is also kind of presupposing that your big A and little a are on a triangle with opposite angle, opposite sides. So this is for labeling this correctly. The big A is opposite of little a, big B is opposite of little b, big C is opposite of little c. So if you mess up those labels, that this kind of formula will not work. So you do want to make sure you label these correctly. So I guess really the law of sines might be the sine of an angle divided by its opposite side is equal to a sine of another angle divided by its opposite side. So in the next video, you'll see me actually work a problem using the law of sines.